Hello, students, and welcome back. We'll be looking today at your Notes 13, which is graphing inequalities and systems of inequalities. So when you graph an inequality, you first of all have to solve the equation for y so that you can find your slope and intercept. You'll use a dashed line if you have the greater than or less than symbol, and you'll use a solid line whenever you have the greater than or equal to, less than or equal to symbol. And then we'll use a test point. So our first problem is already in y form. However, I am going to write it as an equal sign. So y equals, and that's negative 1x plus 3. So our slope is negative 1. I'll write that as a fraction. And our y-intercept is 3, so that we will start on the y-axis at 0, 3. We have a less than or equal to sign in the original problem. So that means that we will use a solid line when we graph. So we'll take a look at the graph for this, again starting it at 0, 3 on the y-axis and moving according to your slope, which is negative 1 over 1, so down 1, right 1. And you want to put enough points on here that when you do draw the line, you can be accurate. So solid line that goes through all of those points, arrows on the line, and then since this was an inequality to begin with, we have to shade the area where the ordered pairs are true for the original statement. So the original statement was y is less than or equal to negative x plus 3. We'll use a test point of 0, 0 to determine where the ordered pairs are that make this true. So and you can always use 0, 0 as long as your line, your boundary line, does not run through it. So we'll plug 0 in for the y. There's no such thing as a negative 0, so we don't need the negative sign for the 0. We'll put it in for x and add 3. So we get a statement that 0 is less than or equal to 3. Well, that is a true statement. So we want to locate where the 0, 0 is in relation to the boundary line. Since we had a true statement, we want to shade on the same side as the 0, 0. So we'll shade on this side of the boundary line. And make sure that you shade that whole area. And that will be your first example. I'm going to go ahead and scroll up to the second example. So if you need to look at that some more, you can just play back the video for that. So I'll clear this ink and move up to our second example. So the second example is 2x minus y, minus 4y is less than 8. This equation is not already solved for y. So we'll have to do some work to make that happen. You'll want to take the 2x, subtracting it to the other side. Remember that the 4 has a negative in front of it. So negative 4y. I'm also going to go ahead and change to an equal sign while I'm doing this. Equals negative 2x plus 8. I'm changing to an equal sign because I'm working with the boundary line. And so the boundary line is an equation. I have to divide by -4. When you do the dividing, you divide every term on both sides of the equal sign. So we'll have y equals, now a negative divided by a negative is a positive. 2/4 reduces to 1/2. So 1/2 x, and then 8 divided by -4 is -2. So we have a slope of 1/2. We have a y-intercept, b, of -2. So a starting point of 0, -2. And your original problem had a less than symbol in it. And so that means we will use a dashed line. It doesn't have the equal to part. And a dashed line means that the boundary line is not included in the solutions. A solid line would mean that it is included. All right, so we begin our graph at 0, -2, and our slope was 1/2. So up 1, right 2, and continue on, up 1, right 2. Make enough points that you are accurate as you draw the line. And this one is dashed. Again, that means the boundary line is not included in the solution. Since we had an inequality to begin with, we will use our original problem. 2x minus 4y is less than 8. Our test point for that original problem again can be 0, 0 because our line does not go through 0, 0. So plugging in 0 for the x and plugging in 0 for the y. Again, you must do this in the original problem. Otherwise, you may have a problem with your inequality. So always do the test point in the original problem. This is going to give you 0 is less than 8. This is again a true statement. So I'm going to locate where our test point is. Test point's at 0, 0. Came out true. So just like the last one, we'll need to cover up on the side or shade in the side where the 0, 0 was. If our 0, 0 test had come up false, then we would have shaded on the opposite side of the dashed line. So this problem is telling us that every ordered pair in this green shaded area is a solution to the original inequality, but any points on the dashed line are not included in that solution. And we'll go on to another video for our backside of the notes.